Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be discussing on organic chemistry, and specifically we are going to be looking at alkanes. We look at some of the preparations of alkanes and then also some physical properties of alkanes. And then look at a few practice questions. So initially we looked at other sources, that's the natural sources of alkanes. So today we are going to look at how we can obtain alkanes in the laboratory. So alkanes, like any other homologous series, have similar chemical properties. And in the laboratory, alkanes are usually prepared for the reaction from the reaction of sodium alkanoate with solid sodium hydroxide or soda lime. So this sodium hydroxide is a mixture of sodium hydroxide and calcium oxide as well. The calcium oxide is used to keep the sodium hydroxide dry. We know sodium hydroxide absorbs moisture from the atmosphere. So the calcium oxide in the mixture is usually helps to prevent that from happening. So when alkane are presented, when they are reacted, especially the sodium alkanoate, we usually pick the sodium alkanoate of the preceding alkane. Let's say, for example, we want to prepare methane. We are going to use sodium ethanoate. If we want to prepare ethane, we are going to use sodium uh, propanoate. So you can see how we move from one proceeding to the other. So that's how we usually do it. And you can see the general equation for the reaction between the alkanoate and sodium hydroxide. So we usually form the alkane and sodium carbonate. So methane can be prepared from sodium ethanoate, and ethane is prepared from sodium propanoate, while propane is prepared from sodium butanoate. So this is a setup for the preparation. So the sodium ethanoate or propanoate is reacted with the soda lime, and it's heated as you can see, and then the methane or ethane is collected over water. So about 5 grams of sodium ethanoate and an equal mass of soda lime is put in a hard glass test tube. Upon mixing them thoroughly in a mortar, the mixture is then heated in the test tube. So one of the observations that we notice is a colorless gas that is collected over water is collected. And the reason why is because methane does not react with and is insoluble in water. So that is the reason why it's possible to collect it over water. Otherwise, if it was soluble, collecting it over water would not work. And the equation for the reaction, as you can see, sodium methanoate reacts with sodium hydroxide to form a methane and sodium carbonate. So let's write the equations for preparation of ethane. So we said for ethane, we are going to use sodium propanoate. So let me write the word equation first, which will react with soda lime to form ethane and sodium carbonate. So let's convert this into a chemical equation. Sodium propanoate is going to be, so you write the propanoate with 3 carbon. So we have the CH3, and then we have CH2, and then the last one is the one that has the sodium plus soda lime, which is sodium hydroxide. It's going to form ethane, so it's CH3, CH3, and then plus sodium carbonate. So you see the equation is balanced because you have 2 sodium both sides. We have one. When you look at the number of carbons, there are 3 both sides. Oxygens are 3 both sides. So that is the equation for the preparation of ethane. For propane, we're going to use sodium butanoate plus soda lime, which is going to form propane plus sodium carbonate. So sodium butanoate, so it's going to be CH3, CH2, CH2, and then that, then plus sodium hydroxide, which is going to form CH3, CH2, CH3, plus sodium carbonate. And finally, for butane, we are going to use sodium pentanoate plus soda lime to form butane plus sodium carbonate. So when you write that equation, it's going to be CH3, CH2, 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 then plus soda lime, which is sodium hydroxide, to form butane and sodium carbonate. So when you look at some of the physical properties next, we notice that methane is a non-poisonous, colorless, and odorless. It is insoluble in water, just like we said before, but it is soluble in organic solvent. So alkanes are nonpolar, so they will definitely dissolve in nonpolar substances. Uh, and then the melting point of alkanes usually increase in number of carbon atoms. So the longer the chain, the stronger the intermolecular forces of attraction. So it means you require more energy to break these forces. Remember when we were talking about the sizes of the molecule, say the bigger the molecule, the stronger the intermolecular forces. In this case, you can see the molecule is larger. And then another property is that the first four alkanes are gases, and you can see why, because of the strength of the intermolecular forces. So high above in the first four, you know they are very weaker, and that's the reason why they are gases. And then the ones that are in between are liquid states, so their strength of the forces are a bit weaker, a bit stronger than the gases. And then when you go to the large ones, like bigger ones, they're usually solid in state because of the strong intermolecular forces, so they have strong bonds. So the density also is directly affected by the strength of the forces and the size of the molecule. So the density of straight chain alkanes increase with increasing carbon chain as the intermolecular forces increase. So they dissolve or they are heavy, their heaviness. Is it lighter or heavy? Depends on their sizes of the molecule. So the bigger the size of the molecule, the more dense it is. The smaller the size of the molecule, the lighter it is. This is attributed to the strength of the intermolecular forces as well. If the forces are stronger, it means it's going to be heavier. If they are weaker, it means it's going to be a bit light. So this reduces the volume occupied by a given mass of a compound. So let's look at a few questions in regards to what we have discussed. The figure below represents the setup that was used to crack an alkane. So write the formula of solid X. So this is basically not to crack, is to prepare. So we have soda lime and solid X, and we are preparing propane. So solid X is going to be sodium butanoate, and the formula is going to be CH3, CH2, CH2, like that. So this is a sodium butanoate. Explain why calcium oxide is added to the mixture above. So we said that we are adding calcium oxide to keep the sodium hydroxide dry because it's the liquescent. It absorbs moisture to form water. Write a balanced equation for the reaction. So we are writing the equation of the sodium butanoate plus sodium hydroxide. Remember we said this forms the first four, we said they are gases. This one is liquid, sodium hydroxide, aqueous to form propane, which is CH3, CH2, CH3, which is gaseous, plus sodium carbonate, which is aqueous. So that is the equation for the reaction. The next question is study the flowchart below and answer the questions that follow. So we have N that reacts with soda lime to produce through step 1 to form sodium carbonate, and P which reacts with excess chlorine to form tetrachloromethane. So I know we have not done this yet. We are going to do it later on. So identify N and P. So from the fact that we have one carbon, it means we are forming methane. So whatever is here is going to be methane. So it means this, whatever we are using here, the identity of N is going to be sodium ethanoate, and P is methane. So this is CH3, CH2, COOO. It's like that, and then this is CH4. Then the last question, study the flowchart below and answer the questions that follow. So substance D and sodium hydroxide are reacted and heated to produce ethane and products. So ethane is produced from, so substance D is going to be sodium propanoate, which is the same as CH3, CH2, C, like that. And then substance C, which is the product, is going to be sodium carbonate. Which is sodium carbonate. So that brings us to the end. So in the next lesson, we are going to be looking at some chemical properties of alkane, and then we'll finish up on alkanes. See you in the next lesson.